Any other questions?
Sir, isa pa po, sir.
Sure, please. Oh.
Pwede po bang gamitin yung voltage divider for parallel circuits?
I don't know if I understand your question well, no? Let's parallel. How do you use voltage divider sa parallel? Kasi if this is the volts here, if this is plus V, bale, yung voltage mo rito, V din, yung voltage mo rito, V, no? This is also V, this is also V.
Opo.
So, I don't know if I understand what you mean by voltage divider, no? Kasi pag parallel, ang assumption nun, basta't lahat naka-parallel, lahat pare-pareho yung voltage.
Okay. Kung may nakaseries po sa isang branch, sir, kung meron pong nakakabit pong isa, bale dalawang resistor po sa loob po ng parallel po na yan, parang dalawang resistor.
Ganyan?
Apo. Tapos parallel po. Tapos,
Ganyan?
apo. Pwede po ba sa branch po na una, sa unang branch po na yan?
Yeah,
Pwede po.
Let's say meron kang plus or minus V dito. Dito, that's V1. Dito, that's V2. You can use voltage divider because this is in series with this. So itong voltage na to will distribute itself. Part of it will go here. Part of it will go here. No? Yun yung parang voltage divider. Kung meron kang total voltage, magdi-distribute yan dun sa mga resistances na naka-series. So part of it will go here, part of it will go here. Pero yung voltage mo rito, V pa rin. No? Kasi nakaparallel siya.
Bale po parang sa series lang. Sige po, sir. Salamat po. Gets po, sir. Thank you po.
Okay. Pero siguraduhin mo naka-series, ha? Kasi pag may nakakabit dito, hindi na pwede.
Okay po, sir.
No?
Apo.
So let's say this is V, tapos dito may nakakabit. Hindi mo na pwedeng gamitin yung voltage divider dito. Kasi hindi na siya naka-series.
Oh, okay po, sir. Sige po. Thank you po.
Okay, welcome.
Sir, question po. So,
Please.
tensya na
No problem.
So, maliwanagin. Yung sa example po, yung sa may wire na, I mean, yung sa yung may gain na example.
Example sa
slides
last week?
Last week po.
Sige, let me bring it up, no?
Yung may ano.
Last week, kailan last week? Tuesday or Thursday?
Example lang ho siya eh. Sige po, Tuesday ho ata yun.
Tuesday. Bato. Which example?
Yung sa dulo, yan ho.
Ito.
Bakit pulit palang dumadaloy na ano sa may linya sa baba?
Wala, no? Kasi yun din yung ina-explain ko kanina, no? Kasi kung meron kang current na dadaan dito, no? Kailangan nakakabalik siya. Kung dito siya nag-uumpisa, kailangan yung current flow nakakabalik dito sa point na to, no? So, saan pupunta dito to, no? Parang wala siyang babalikan dito to go back here, eh. No? Yung current mo has to have a path to go back to where it started from. So kung dito mag-uumpisa yung charges mo, let's say mag-flow siya pa ganito, aakyat siya dyan, paano siya babalik, no? Wala kang babalikan dito. Hindi naman pwedeng ito papasok dito tapos paikot-ikot lang dyan. Hindi pwede, ano? it has to go back to where it came from. That's why yung current dito will be equal to 0.
So,
In other
sir, dun sa tinanong ko sa may diagonal, since babalik naman siya, ibig sabihin may ano na dudaloy pa rin doon?
San babalik?
Since may babalik siya dun sa node na yun.
Which, dito sa figure na to?
Hindi po, sa example na tinanong ko kanina. Ay, ako po kasi nagtanong kanina nung sa ano.
Yung resistor na ganyan?
Ay, hindi. Yung kanina, yung una ho.
Yung ganyan?
Hindi ho. Yung kanina pa po.
Ano bang tinanong mo? Sorry matanda
Ay,
na ako.
Yung sa ano po, yung sa problem set. Yung sa may diagonal.
Aha. Yung ganyan.
Apo.
Okay. So, let's say meron kang current dito, no? Some of that will go here, some of that will go here. Basta may path siya. May path siya para bumalik dito. No? Let's say mag-umpisa siya rito, let's say paikot siyang ganon, may path siya na babalik siya rito or may path siya na babalik siya rito.
Okay po, sir. Thank you po. Gets ko na po.
Pero dito, kahit na anong gawin ko, wala akong makikitang path na makakabalik siya rito. Kahit na anong gawin ko rito. Dito kita mo may paraan. Basta't may paraan na bumalik siya doon sa pinanggalingan niya, then pwedeng dumalo yung kuryente natin.
Thank you po, sir.
Okay. Actually, kaya lang for all intents and purposes, this act like two separate circuits. Parang ito isang sirketo to. Ito isang sirketo din yan, ano? Kaya lang naglagay ng linya rito sa gitna is because gusto mag-establish ng common reference. No? Sa mga sa ngayon hindi mo pa nakikita, no? But sa mga future courses, mga circuits na ganito, may ini-establish na common reference ito. Ito yung parang nagiging common ground ng buong circuit. But in terms of behavior, itong circuit sa left side at saka itong circuit sa right side can actually be treated independent of each other. Sa libro, pag tinignan mo yung libro, ang tawag dito, these are disjoint circuits. Parang yun ang tinatawag nilang disjoint circuits. Okay, those are good questions, no? Huwag kayong mahihiyang magtanong. Kasi pag medyo hindi ka talaga sanay sa circuit analysis, pag minsan medyo nakakalito talaga, no? Any other questions? Okay, so tuloy natin yung discussion natin last time. By the way, may tanong ba sa nodal analysis sa kinuha natin last week? Wala naman. Okay, so ang ginagawa lang natin ngayon is we're showing how nodal analysis can be applied under different circumstances. Kasi yung unang example na kinuha natin last Tuesday, yung unang example, yun very straightforward yun. we could easily apply KCL to any of the nodes in the circuit. Pero nakita nyo dun sa second example, it was no longer possible to apply KCL dun sa nodes sa circuit, sa certain to certain nodes in the circuit because of certain unknowns that you were going to introduce, no? So yun yung nangyari when you have, yun yung mangyayari when you have a floating voltage source. And then we gave an example. Now, what if you have a controlled source? Okay, so that was the third example that we gave. How do you apply nodal analysis or the node? By the way, nodal analysis is also called the node voltage method. And then finally here in this example, I combine the two. No, what if I have a floating dependent source? Okay, so this is my example. Very similar to my floating voltage source example, except that pinaltan ko to ng floating dependent source. Okay, the problem is, how do you get VA, VB, and VC? Okay. Dito sa A, madaling-madali nating makukuha yung KCL equation. In fact, it's if I'm not mistaken, it's identical to the example that I gave earlier, no? Yung second example natin. But okay, let's do the KCL for A. For A. So dito, I do a KCL here. So what is this current? Itong current na to. This current is VA minus VC all over 8. And then I have this current, no, from A to B, that's plus VA minus VB over 6. And then I have this current. What is this? Is this positive or negative? No? Sagutin niyo ako. Positive or negative?
Negative po.
Negative, right? Minus 3 is equal to 0. Okay, so that's for A. May makikita natin dito, or rather dito sa B or sa C, hindi tayo makakapag-KCL without introducing a new unknown, no? Kaya hindi tayo makapag-KCL kasi hindi ko alam kung ano itong current na to. Ito yung current na dumadaan sa controlled source na to, no? Or dependent source na to. So ano yung solution natin? We learned before that in such a case, you combine this two into a supernode. You combine this into a supernode. And then what you do is you get the equation for the supernode. So what are my currents associated with the supernode? I have this current from B to A. So what is this? This is VB minus VA over 6. Okay. Then I have this current, VB going toward ground. So that's VB over 3. Ano pa? I have this current from C to A. From C to A. So this is plus VC minus VA all over 8. Then I have from C to ground plus, tuloy ko rito, no? VC over 4 minus 5, negative, no? Dahil papasok, hindi palabas, is equal to 0. Okay, so ngayon kulang ako ng isang equation. Ano yung information dito sa circuit na to na hindi pa lumalabas dito sa dalawang equation na to? Ang hindi pa nagagamit na information is this. Okay, what does the controlled voltage source do? It constrains the voltage between node B and node C. In other words, VC minus VB is equal to the value of the controlled voltage source, which is 2Vx. Again, bakit VC minus VB? Bakit hindi VB minus VC? Dahil sa polarity nito. The polarity here shows you that the right side is of a higher potential than the left side, and therefore it should be VC minus VB. No? But wait a minute. No? This is an unknown. So actually, there are 4 unknowns here, 3 equations. But actually, the value of Vx can very easily be expressed in terms of VA, VB, or VC. So anong value ng Vx? Anyone? Tell me. What is Vx?
VA minus VC over 8.
We're talking about voltage, no? We're not talking about current.
Ay, oh yes. So, VA minus VC po pala.
Okay, that's right, no? So Vx is, itong Vx is VA minus VC. It's good also that you made that mistake, ano? Because common mistake talaga, pag minsan when we write out our equations, we end up we end up mixing up voltages and currents. Remember that you cannot add voltages and currents together. If you're going to add terms, you add voltage terms together or you add current terms together, but never add a voltage to a current. No? So anyway, what is this? This is 2 times VA minus VC. So I have one equation here, I have another equation here, and this is my third equation. So it's now simply 3 equations, 3 unknowns. Again, like I said, this is just a calculator problem now, calculator entry problem. Of course, you have to simplify the equations, put it in standard form, then do your calculator entry, and tapos na boxing. No? So anyway, just to show you, this is exactly what we wrote down. No? The equation for A, the supernode, no? The equation for the supernode BC, and then expressing or the constraint imposed by the control voltage source on B and C. So VB minus VC is 2Vx. Vx is equal to VA minus VC. And finally, you get these values after solving the simultaneous equations. Any questions? Any questions?
Sir,
Yes, sir.
bakit po Vx equals VA minus VC po ulit, sir?
Sandali, no? Nawala yung sharing ko, just a while. Can everybody see my screen again?
Opo, sir.
Yeah. Bakit Vx is equal to VA minus VC? Tignan mo yung polarity ng Vx. No? Ang assumed polarity niya is the left side is positive with respect to the right. Therefore, dapat ito mas mataas yung potential kaysa dito sa side na to. No? So that's why Vx is equal to VA minus VC. Does that answer your question?
Opo, sir.
Okay.
Salamat po.
Any other questions? Okay, the rest of the class, like I said, no, matatapos tayo maaga ngayon. The rest of the class, we'll just do some exercises. So, this is the first exercise. Ang ginawa dito sa exercise na to is, iniba lang, no? Usually kasi ang known quantities mo are your resistances and your sources. And then your unknown quantities are the node voltages, no? So this time, binaliktad lang, no? Ang binigay na known quantities are the node voltages plus some of the resistances, and then your unknown quantity is one particular resistor and one particular source. Okay, I'm going to let you solve this, no? The value of R, so the problem here is, binigay yung value ng VA, binigay yung value ng VB, that's 7 volts and 10 volts respectively. You're supposed to solve for IS and also solve for R. No? the value of is and the value of r can be solved without having to solve simultaneous equations. I'm telling you that right now, no? So can I ask you to try to solve initially for the value of r, no? Take a few minutes at it. Pretend this is a quiz that you're taking in UVLE. Kasi typical to, no? Typical type of problem na makikita nyo in UVLE sa mga quizzes. It should take you only a few minutes to solve. So can you try solving for the value of r? Once you get an answer, send it to me privately. And after I've gotten several responses, no, let's try to do it. Let's try to do it together. Okay, so can you do that right now? Ang hinihingi ko lang yung value ng r. So if somebody can, if people can start messaging me, ano yung kinompute nilang value ng r? Please try, no? Dun sa mga nandito ngayon, just don't listen. You should try solving the problem. Medyo natatagalan ata kayo, no? Okay, I already have an attempt from someone. Miss Ira, please try again. No? Please try again. But it's a good try. Okay, I have one correct answer already. Patrick, please try again. Please try again. So yung sagot ni Cedric tama. The others, please. I encourage Ira and Patrick to please please try again. I only have answers from 4 people. There are 10 of you here. Danielle, sorry, please try again. Okay, see, Moray is correct. Si Mark solved for both, no? And they are both correct. Pero R lang muna, no? Masyadong nauna si Mark. In fact, Mark gave the answer away to everyone else. So alam na ng lahat ng tao kung ano yung tamang sagot. It's okay, no problem. Okay, so ginawa na rin ni Mark, ano? So let's do it together. Yung pag-solve ng value ng R is very straightforward. All you have to do is apply KCL at A. KCL at A. So KCL dito sa node na to. So what are the currents that are leaving this particular node? No? What are the currents that are leaving this particular node? Well, this one is entering, so it's negative, no? So -2. What is this current flowing in R going down? No? So that's plus VA over R, no? Yung current na bumababa dito. What is the current flowing here to the 4 ohms? So that's plus VA over 4. And finally, what is your current from A to B here? That's plus VA minus VB over 2 is equal to 0, no? And then you just substitute. VA is 7, VB is equal to 2, no? So you have -2 plus 7 over R plus 10, plus 7 over 4 plus 7 minus 10 over 2 is equal to 0. So for R, you're going to get R is equal to 4 ohms. Okay. Any question with regard to that? Any question? I want to hear from the ones that got the wrong answer. No, I just want you to share. No, saan kayo ang kamali? Can you please share with the others where you made a mistake? Sino ba mga nagkamali? No. For example, si Ira Nicole, where did you make a mistake?
Sir, hindi ko po na-incorporate yung other voltages. Kala ko po yung sa across the resistor lang po.
Okay, okay. Pero okay na. I mean, you saw already what you did wrong.
Yes po. Naiintindihan ko na po.
Okay. Yeah, because remember that when you do a KCL4 here, you have as many terms as the number of branches that are connected to that particular node. No? So I have four branches that are connected to A, and therefore I should have 4 terms in my equation. That's why I have 4 terms here. One very common mistake when you're applying KCL is may nakakalimutan kang isang branch. Okay, so IS, how do we get IS? To get IS, you just apply KCL at B. And this is even easier. So what are the currents associated with B? So first you have IS entering, so that's negative minus IS, okay, plus then your current flowing down here, so that's plus VB over 8. And then you have a current flowing down here also. Actually, the two 8s are in parallel, but anyway, let's do it separately. VB over 8. Kasi yung isang pwede mong gawin, itong dalawang 8 ohms nakaparallel. What is 8 ohms in parallel with 8 ohms? That's just 4 ohms. No? If you combine these two terms, you're just going to get VB over 4. So it's just that, no? And then here you have plus VB minus VA over 2. That's this current here. This is equal to 0. So minus IS is equal plus, okay, 7/8 plus 7/8 plus 3/2 is equal to 0. You solve for IS, you get IS is equal to 4 amperes. Don't forget the units. Whenever you have an answer, always specify the units. So any questions with regard to this problem? So again, no, I just want to mention, this is typical of a problem you'd see in a quiz in UVLE, because the level of difficulty is such that you should be able to solve the problem in just a few minutes. Just a few minutes. Let's move to another example. No? Okay, this one I'm going to do this. I hope you can follow. Get an expression for the voltage at X in terms of the conductances of R1, R2, and R3 show that the voltage at X is actually the weighted average of V1, V2, and V3 if the weights are the conductances of R1, R2, and R3. Parang ano, no? Parang nakakatakot pakinggan, ano? But actually, it's quite simple. So, the assumption here is there's nothing connected to X. Okay? Nothing connected to X. Dito sa right, ha? Wala nakakabit dito sa X sa right. Sa left side, you have these 3 branches. And therefore, your KCL equation for X will only have 3 terms. So KCL at X, what do I have? I have Vx minus V1 over R1 plus Vx minus V2 over R2 plus Vx minus V3 over R3 is equal to 0. Nakita ba niyo yung bakit Vx minus V1? This is our reference node. That's our reference node. And therefore, this voltage is equal to V1. No? This node voltage is equal to V2. And this node voltage is equal to V3. No? So if you consider these to be nodes, actually they are nodes. It's just that they are non-essential nodes. But these are actually nodes. Then the node voltage here is V1, the node voltage here is V2, and the node voltage here is V3. So we have Vx minus V3 over R3, no? Vx minus V2 over R2, and so forth. No? Here we have Vx minus V1 over R1. In terms of conductance, I have G1 multiplied by Vx minus V1 plus G2 multiplied by Vx minus V2 plus G3 multiplied by Vx minus V3 is equal to 0. Because what is G? G is just 1 over R. Right? So if I simplify, I'm going to get Vx multiplied by G1 plus G2 plus G3. And then putting all other terms in the other side of the equation, I'm going to get G1 V1 plus G2 V2 plus G3 V3. Or Vx is equal to G1 V1 plus G2 V2 plus G3 V3. Okay, all over G1 plus G2 plus G3. This is actually a weighted average equation. Okay. V1, V2, and V3 are your values. G1, G2, and G3 are your weights. So the weights are established by the resistances, and the values are established by the voltage. What's an example of a weighted average? Can somebody tell me or give me an example of a weighted average? Exactly, no? Exactly. Your grade your grade weight average for the semester. So kung for example, ano yung grades mo, no? Semester grades. No? So subject, grade, then units, no? So subject 1, subject 2, subject 3. Sabihin natin dito 1 kayo, that's 3 units. Dito 2 kayo, that's 3 units. Dito na 5 kayo, sorry na lang, that's 5 units. Ito yung value. Ito yung weight. Anong formula mo for your GWA? Ang GWA mo would be what, no? 1 times 3 plus 2 times 3 plus 5 times 5 over 3 plus 3 plus 5. Okay. So this is a simple illustration that you can actually use electric circuits to do calculations. In fact, in the olden times, nung unang panahon, no, analog computers, there were no digital computers. It was just analog computers. And you had a lot of circuits built like this to do analog calculations. Okay? Those analog calculations, for example, would be in control systems or in not so much for numerical computation, but maybe in implementing, for example, industrial control systems or something. No? So anyway, that's just a little bit of history. Any question with regard to this example? Okay, let me move to a third exercise. I want you to try to solve this problem. The problem is determine the values of V1, V2, and V3. No? What I want you to do, I want you to just try setting up the equations. And then, okay, if you run into any difficulty or you run into some complication while trying to set up the equations, I want you to tell me what problem you're running into through the chat. No? Okay, so can you do that? And it's okay if you send it to everyone. No? It doesn't have to be a private chat. So please try to do that, no? Solving for V1, V2, and V3 using nodal analysis or using the node voltage method. Tapos sabihin niyo sa akin kung saan kayo, kung mahirapan man kayo, sabihin niyo sa akin saan kayo nahihirapan. No? Kung hindi kayo mahirapan, then well and good. No? Okay, are you starting to encounter issues with regard to the equations you're setting up? Can you share with the class ano yung mga issues na encuentro ninyo? Or have you been able to set up the nodal equations already? It's very quiet. Anong nangyayari? Meron na bang success?
Sir? Sir?
Yes, Ivan,
Sir, kasi po yung voltage sources, parang connected po sila. But i-minus po ba yung ano nila, yung values nila, tapos yun na po yung parang magiging sinusupply niya sa V2, V3?
V2, V3.
Kasi at V1 po, sir, parang medyo nagkakaproblema po ako doon kasi wala po akong nakukuha parang expression for the current from V1 to V3 and V1 to V2. So parang baka po isa siyang parang isi-simplify siya na voltage source, like isasubtract po yung values.
Tama ka, no? That effectively the voltage between V2 and V3 would be kasi you can basically ang sinasabi mo magki-KVL ka dito sa malaking loop na to, and effectively makukuha mo nga yung voltage between V2 and V3 by subtracting itong voltage na to from this voltage, no? But I don't know whether you'll achieve anything from that.
Okay, so mag-try na lang po na iba.
No, I mean it's something you definitely can do, but I don't know whether it will help you solve the problem, no, of determining what V1, V2, and in effect, nakuha mo yung voltage between V2 and V3. Pero ang problem dito is what is V1, what is V2, and what is V3.
Okay, sir. Thank you po.
Ang ginawa mo is, alam mo kung ano yung V2 minus V3, basically. Kasi nag-KVL ka dito sa malaking loop na to. At saka hindi na yan aligned with yung method natin, no? Which is the node voltage method. Although I'm not saying it's a bad way of solving the problem, no? So anyway, naririnig ko na some of the complications that you're facing, no? Anybody else want to comment on the circuit?
Sir, bawal bang mag-supernode sa V1, V2, tsaka V1, V3?
Actually, yes, no? Kasi okay, so sinabi mo na rin, ano? If you try to do KCL in any of these nodes, magkakaproblema ka. Right? Bakit problema ang KCL dito sa V1?
Kasi
right? Kasi hindi mo alam kung ano yung current dito, hindi mo alam yung anong current dito, no? Di ba? So hindi ka pwede mag-KCL diyan. Hindi ka rin pwede mag-KCL dito dahil meron kang source dito, voltage source, hindi mo alam yung current. Dito, hindi mo alam itong current. Right? So, parang at the onset, okay, I'm supposed to apply the node voltage method, which means I should do a KCL. Saan ako magki-KCL? Yun ang parang nagiging problema dito sa circuit na to. Right? So for those of you that are stuck, talaga this problem is intended to make you think, ano yung kailangan kong gawin dito? So sinabi mo na supernode. Ano ang magiging supernode ko? So who is that one that answered na supernode? Sorry.
Ako po, sir.
Teka, hindi kita makita eh. Aquino?
Apo.
Okay.
Yung sa V1, tsaka yung may mga voltages po, yun po yung gagawing supernode.
Okay, so anong suggestion mo? Okay, let's see, no? Ito ba? Ito gagawin nating supernode?
Apo.
Okay, kung gawin nating supernode yan, ano yung mga currents ko, no? I have a current here, I have a current here, and well, current there. Can I get expressions for all those currents?
Yung sa may voltage po parang hindi, di ba?
Okay, hindi ano? Kasi may problema ka pa dito eh. Hindi mo alam kung ano yung current dito eh.
Apo.
So ano yung
So mas maganda po kung gagawin mo munang supernode sa V1 tsaka V3 kasi lahat naman siya may current doon.
ito?
Hindi mali pala kasi yung may 8 volts pa pala.
Oh, okay. So ano na? Sana tayo?
Sir, pwede po ba natin i-supernode yung from lahat na from V2, V1 to V3? So
Okay.
bali,
Very good. That's what you should do. No? Ang gagawin mong supernode, basically, okay, based on this drawing, ito ang gawin nating supernode. In effect, it's a supernode, no? Yan ang gawin nating supernode. Okay? So, ano ang mga currents dito? I have this current, I have this current, I have this current, and then ito, pumapasok dito pero lumalabas dito. Right? So what is my equation? What is my equation? For example, ano itong current na to? Dito. That's just V1 over 4. No? What is this current here? That's V2 over 10. And then what is this current here? That's a V3 over 5. Okay? Tapos meron akong lumalabas dito. That's 0.25. Pero pumapasok siya uli rito. So magiging minus 0.25. And this is equal to 0. So this cancels out with this. Right? So there are 4 currents entering the supernode, no? You have 1, you have 1, 2, 3, ito, at saka ito. Pero ito, nagka-cancel out dito. Okay? So that's one equation. What are my other equations? Anyone? What are my other equations? Kasi, in effect, I have one supernode. In fact, I only have one supernode in the entire circuit, no other nodes. So I can only form one equation. I need 2 more equations. So from Paulo,
V3 minus V1.
okay,
Equals
V3 minus V1
equals 12.
is equal to 12. And then may sagot din through the chat, no? Si Juan Paulo. V2 minus V1 is equal to 8. So this is one equation, second equation, third equation. I can now solve my problem. Actually, mas madaling makita to if I redraw the circuit. Let me just redraw the circuit. Let's say this is V3. No? Tapos meron akong plus or minus 12 volts. Ito yung V1. Tapos meron akong minus plus 8 volts. Okay? Minus plus 8 volts. Sandali, ano? I'm having technical problems. Okay, so V3, let me just clear this up. Minus plus 8 volts. And then this is V2. And then V3 to ground, this is 5 ohms. V1 to ground, you have 4 ohms. V2 to ground, you have 10 ohms. Okay, so lahat ito is just ground. Tapos V3 to V2 or V3 to V2. Meron akong current source na ganyan, no? So, ang tanong ko, ano kung ito yung ginawa kong supernode? Would I have come up with a different set of equations? Kasi ang ginawa kong supernode dito sa kaliwa, ang ginawa kong supernode, ito lang, ano? Ito lang. So ngayon, ang ginagawa kong supernode, itong malaking to. Mag-iiba ba yung mga equations ko? So that's my question.
Sir, parang hindi po mag-iiba, sir.
Hindi mag-iiba, di ba?
Yes, sir. Kasi like dito naman po yung 0.25 amperes, nag-cancel lang naman din po siya kahit ito po yung
Exactly.
supernode.
Yeah, exactly, no? So in effect, I could have made my supernode include this 0.25 amperes. So in combining nodes into supernodes, you can actually combine all the elements that are between those nodes into the supernode, and it should not affect your supernode equation. In fact, this needn't have been a current source, no? This could have been a resistor, right? If this was a resistor, for example, if this is a resistor, yung current na pumapasok dito, yun din yung current na lalabas dyan. So magka-cancel out pa rin. Okay? In other words, if this is a resistor, dito yung going in this direction is V3 minus V2 over R, and then dito, going in this direction is V2 minus V3 over R, nagka-cancel out. So I'm just telling you that you have a choice, no? You could have defined this as your supernode, or you could have defined this whole thing as your supernode. And then the three currents are now this current. Ang tatlong current natin is this current, and this current. So yan yung equation nito. And notice also that if I had done a KCL dito sa ground, I would have gotten this equation. Although medyo ano lang yan, ano? That's just characteristic of this problem. That the equation of my supernode is also the KCL equation at my ground terminal. Normally in the node voltage method or the nodal analysis method, normally we don't do a KCL sa ground. Kasi nga, kaya nga natin ginawang reference yan, no? When we say it's the reference, that means we consider it to be the redundant KCL equation. Naalala nyo? If you have n nodes, you have n minus 1 valid KCL equation. So ang ginagawa nating redundant KCL equation is usually the KCL equation sa ground. So we don't normally do a KCL sa ground. That's just what I want to say. So any question with regard to this exercise? Parang binibigyan ko lang kayo ng flavor of some of the things you might encounter. And then when you encounter things like this, you just have to go back to basics. That's actually my last slide for today. That ends the formal discussion on the nodal analysis method. So I'm going to release, no? I'm also in charge of this week, so I'm going to release a quiz. That quiz is going to be released right after, it will be active right after the quiz 2 becomes inactive. And then I'm also going to be releasing a problem set this weekend. Any questions? Sorry, somebody's trying to talk, hindi ko marinig.
Hello po. Hello.
Please, go ahead.
Yung sa KCL po sa resistor, paano po malalaman yung direction niya? Kunyari, dyan sa to the ground, sa may example na yan, paano po nalaman yung
Ito.
Nalilito po ako sa direction.
The direction actually depends on you no? Kasi kung ang sinabi kong direction, okay. Let's say ito yung ginawa kong direction, no? Yan. So
Okay.
anong ibig sabihin, no? Pag yan ang direction, unang-una, aling term yan? Ito, no? This term is going to be negative. Right? This term is going to be negative. And then, the voltage across this resistor is going to be 0 minus V3. Right? Because if I assume the direction is going up, then that means that my ground potential is a higher potential than my V3. So the voltage, this voltage is going to be this polarity, di ba? Kasi ganito yung direction ng current, ganito yung polarity ng voltage. Anong value nitong voltage na to? 0 minus V3.
Okay.
So yung term ko is going to be negative and then 0 minus V3 over 5. Okay? Which is the same as V3 over 5.
So assume polarity lang po, sir.
Yeah, the direction is just assumed. It's always just assumed.
Okay po.
But when you assume a direction for current, then kailangan consistent ka sa polarity ng voltage. No? Kasi resistor yan. Naalala mo, resistor, pag nag-assume ka ng current na ganyan sa resistor, ibig sabihin yung polarity ganyan. And therefore, your VR would be equal to VA minus VB. No? But if this is A, this is B, I assume current in this direction, ito ang magiging polarity ko, then my VR is going to be VB minus VA. So pwede kang mag-assume ng ganito, pwede kang mag-assume ng ganito. Pero kailangan yung polarity mo ng voltage laging consistent with the direction of current. Tapos pag nagki-KCL ka, syempre kailangan alagaan mo yung sign. Kung palabas dun sa node, positive, by convention, pag papasok sa node, negative. And you're going to find out, whatever assumption you make, you're always going to get the same expression.
Thank you po, sir.
Yung suggestion ko, no? My suggestion, kung hindi mo alam yung direction ng current, my suggestion is always make it going away from the node. Kasi kung always going away from the node, lahat ng terms mo, kagaya dito, become positive. But that's just a suggestion. Kung medyo mas komportable ka na going toward the node, pwede rin. Those are good questions. I'm glad you asked those questions. Any other question? Pagbaguhan ka talagang, pag minsan nakakalito yung polarity at saka yung mga direction ng current. Later on, pag medyo sanay na sanay ka, it's going to come naturally. Any other questions? Anyway, some of you might want to spend time doing your problem set or doing your quiz. So ganito gawin ko, no? I'll stay online. If there are people that want to talk to me, they can just shout out or they can just type in the chat box. Pag lahat kayo nag-log out na, then that's the time I'll end the session. No? So officially, tapos na tayo for today. Okay? So there's a question here, kapag current source ang polarity ay from current source. Iba pinag-uusapan natin pag current source. May question dito, no? Kapag current source ang polarity ay from plus to minus din, remember that, sorry. Okay, let's talk about sources. Talk about sources. sources typically deliver power. Okay, so anong ibig sabihin nun? If typically they deliver power. Ang ibig sabihin nun, as your charges are going through the source, they are gaining energy. Because the source is transferring energy to the charges. No? The source is delivering power, so it's transferring energy to the charges. Therefore, when it comes out of the source, when your charge comes out of the source, it will be of a higher potential than when it is entering the source. Kaya ang polarity mo would be this way. Okay? So, ganito yung magiging polarity ng voltage across a current source. The same thing with current through a voltage source. No? Ganito yung magiging current mo. Ang resistor is passive. No? You call this a passive device. When you have a passive device, that means your charges lose energy as it is passing through the device, or the device is absorbing energy. That's why if the current is this way, when the charges enter the device, it will be of a higher potential. When it leaves the device, it will be of a lower potential. Because it is the passive device is absorbing energy. So you can think of it that way. Okay. Okay. So like I said, no, for those of you that already want to work on other things, you might have lots of work to do. You can log out. I will stay until the last person logs out. No? For as long as there's a question, I will answer the question. But I'll already stop the recording right now.